Howdy again, it's Tubalcain, your YouTube shop teacher, and welcome back to part 6 of my build on the STUART Progress engine. So let's get started, but first I wanted to show you that I just found this catalog that I had been looking for, and this was the 1978 Coles catalog that sold all of the STUART engines as well as others, and that's what their catalogs looked like for the majority of the years they were in business. They were a good firm until it finally went to pot. So continuing on this, you saw me make the cylinder in the last episode. So in this one I want to start making the head and the rear cover. So let's talk a little bit about that. First of all, both of these castings have what they call a spigot. I call it a stem. They also call it a tenon. And the purpose of that is to hold it in the chuck. The problem is this is tapered because necessarily so it was a tapered pattern to pull out, and that produces a tapered casting. So you can't hold it by that. It's just not going to be firm. If it was aluminum, you probably could. It would conform, but not the cast iron. So I've already done this off camera. I put this in the Atlas lathe, and I used a parallel in there temporarily to stick it out, and I turned down the end of the spigot as well as I could, and it didn't totally clean up. But this will allow me that spigot to hang on to while I turn it in the lathe, and then I'll take this out now because I'm going to do it in the closing lathe, which is just a little bit of overkill, but I can set the camera up so much easier and better on that lathe than the Atlas lathe, so that's why I'm selecting that lathe. This would be a good project that could be done on smaller lathes such as the Shoreline and the Unimat and so on. Looking at the drawing, I know I'm kind of shaky here. I penciled in these numbers here that the small diameter is to be a ½ inch because that's going to fit into the bore. The large diameter, which is about the diameter of the cylinder, is 1 3/16, and the length of the step, and this is out of scale, is 1/32 of an inch. Notice that I have it held in the 3-jaw chuck by that stem, and I am using high-speed steel tool. Why? Because all of my carbide tooling, and yours too for that matter, has a radius on the end, and I wanted a sharp point to do that shoulder. So the first thing I will do is to face it off. And I'm not too concerned about the overall thickness. I don't think that really much matters. My camera lost focus there for some reason, so I lost a little bit of the footage, but that's been faced off and I could care less about the finish, and now I'm turning the periphery and I'm going to take it down to 1.200. Just a little more, and I'm done with the diameter. Alright, now I'm going to turn the step. This is ½ inch rod here, and I'm just bringing that up to help me establish the approximate diameter for this step. The overall thickness was way too great, so I took this down to about 1/8 of an inch. There's no dimension on that, but I'm just going for proportion. And this should be my final pass. The step here is way too long, and I'll trim that later on, but I want this to be 500 thousandths. Doesn't quite go on. Another thousandth maybe. Okay. Looks good. It doesn't need to be real tight. Remember, there's going to be a gasket of some kind here, or sealant. And the only thing left to do on this side is later on reduce the length here, because the way it is, it would block the steam port. However, I may have to notch that anyway, I don't know. I'd like to clean up the other side of the casting, but notice in the drawing here that we have a bolt circle, and the bolt circle is 7/8 inch diameter, or 7/16 radius. So I will try to lay that out, and I'm going to show you how. I'm going to try to lay it out on the lathe. The circle anyway, not the holes. So I will hold it by the step, and that's why I left the step a little longer, so I got something to grip onto. The 1/32nd step would not have been long enough to grip. It would have been too scary. So I need to saw off and clean up the stem here. That we don't have no use for that anymore. Unfortunately, it will not have the appearance of the casting. I like that rough appearance of the casting, but I'm going to saw it off and try to blend it in just a little bit with a file. You can see I sawed it off. Just a little more work. I would like to lay out my bolt circle while it's in the lathe, and you'll see why in a few minutes. Remember, it's a 7/8 diameter bolt circle. Now what I did is, again, filed that down, and then I put a little Sharpie on there, and then with the dead center in the tailstock, I more or less rammed it, gently of course, to find the center. Now, of all things, I've got my threading tool in there, and you say, what do you got a threading tool for? Simply because it's a sharp tool, and I have aligned that with the center point. Is this making any sense at all? Then I already did a dry run using a dial indicator, and you can use a dial indicator, but also I'm just going to dial it in with the cross slide. 437 thousandths, but since this is direct reading, actual dials, I'm going to dial it in 7/8. Is that clear as mud? 2, 4, 6, 8, 75. So now when I turn the lathe on, and I have to use reverse, why am I using reverse? Because I ran into clearance problems here, coming the other way. That's why I dialed it away from me rather than toward me. But now turning the lathe on in reverse, if I can scribe ever so lightly a line, if the casting is running fairly true, hope it is, so that the line will be of equal depth throughout the diameter. Oh, forgot already. I put it in forward. I want reverse. And there it is. perfect circle piston ring. I think I can take it out now. We'll go over to the bench. That bolt circle is dangerously close to this radius here when I get these tiny little screws in there, but I guess there's clearance without hitting it. And you're saying, well, why didn't the fool just take a dividers and do that? And I could have, but what bothered me there was the difference in heights. But I have this set at 7/16 according to a ruler, and you know, and I think it would have been okay to swing the circle that way, because it's pretty close, almost, or I could have opened it just a little bit. But the reason I'm doing that, I wanted to show you something different, and I think I did this 55 years ago. Let's take a look. I'm a sentimental old fool. Now, this is my Stuart number 9 that I made when I was 16, and I distinctly remember standing at a South Bend lathe in my dad, Norman Peterson's class, having him show me how to turn that circle, and I did that on the lathe, not with the divider. So I guess that's why I did it the way I just showed you. You know, there are countless ways to lay out your 6 holes on the circle, and this is the most common way, and that's the way I used as a boy, that my dad showed me. But it doesn't come out even, but it came out close enough to where it didn't matter. But doing it like this and then working, there's 3 of them laid out already, 4, 5, and then 6. But notice that the 6th one here, are you following me? Doesn't quite come out even, you know. So you could make minor adjustments and split the difference, but again, it wouldn't make any difference. So you can do it that way if the spirit moves you. But guess what? This could be done on a rotary table, and I even considered doing that, and then there would be no need to even lay it out, but it would take much longer. The setup alone would take half an hour, and most people don't have a rotary table, so I'm just simply going to lay it out by the B'gosh and B'gosh method like I just showed you with the compass, only I'm going to use the dividers, and I'm going to do that off camera, and I'll see you in a few minutes. Okay. The 6 holes have been laid out by that crude method and then center punch, and now I'm sitting here at the bench with my micro drill, my camera on, and I'm going to pre-drill all of those 1/16 inch with good lighting and the old optivisor. Better get my hand out of the way. And so on for all 6. I don't really have to go all the way through. Now I'm ready to drill and tap, and I'm going to show you a foolproof method of doing this because it can be difficult to do, especially if you've never done it before. But first of all, you need to orient the screw holes here such that we do not drill into the steam passages. So I put a little mark on there. Later I'll put a permanent mark on there, that green mark. That puts one of the holes right up at the top. So what I'm going to do now in this little drill press is, this is the tap drill size. Now that's a 47, and then a 39 is going to be the clearance. So I'm going to drill right through the cover and into the cylinder casting with this drill bit to a depth of, well, I got it marked here, I forgot what it was, but you mark your drill or set a depth stop or something. Then I will take this apart. I'll go to the other drill press and drill that hole out, the clearance size, which I just showed you on the card there. Then I will tap that one hole. Then I will assemble it, put one of those screws in to hold it in place, and then do the 5 others in the same way. That way It's just a guaranteed fit. And don't break off your drill or your tap. And it really doesn't matter which hole you start with. Now I'm into the cylinder. Clear your chips. And now I'm drilling the clearance hole, and why am I using another drill press? Just to avoid the agony of constant tool changes. And now I'll tap that first hole, and look at how small the tap wrench is. That's the very smallest one that I had. And I wouldn't mind it if I had one slightly smaller than that. Some of you may have not seen the first part and you're wondering why I'm not using lubricant. Well, you don't really need it with cast iron. It's self-lubricating. Remember, this is 7BA. Holy mackerel, was that tedious. Remember Enco? Another thing of the past. But there's the first hole with the tiny little screw. And I finally did find a tiny little Craftsman 5/32 nut driver. Do not confuse that with a regular size nut driver. I thought I had a set of those that were branded Exolite. I think they made some electronic type tools. So I'll just snug that ever so lightly. Now I am ready to drill all 5 holes with the 47 to the right depth. Then take the cover off, drill the clearance holes, tap all the holes, and reassemble it. Now, judging from how long this took me to do one, I got about half the afternoon tied up in doing the other 5, so I'll see you when those are done. Those are my permanent witness marks. They're on the bottom, not that it matters. But as you can see, I've got all 6 holes drilled. Only one has been tapped here so far. And I have to open up those, and then I'll put this in the lathe off camera and reduce the length of this step so it does not cover the port. Well, there it is. Now I used first a taper tap and then a plug tap. I don't know where I got this little tap wrench. It's about useless. It looks like it came out of a box of Cracker Jack, but I do like this little sterret. So that side is done. Now I'm going to do much the same to the other side. I have faced this down so there's, well, it's probably a little more, it's probably a 1/16 of an inch. But it does cover up the steam port just a little bit, so I will have to doctor it up and notch it just a little bit in the area of the red mark there, or that can be tapered off too, but just so that the steam can get in there and this doesn't act as a plug. Now as far as the other end is concerned, there's a great similarity. This is the tenon again, except that this one requires a packing box, a stuffing box. And this little brass casting is what would be the stuffing box. And the purpose of that, if you haven't heard that term, is you take that packing material, that graphite packing material like this, and you would wrap it around the shaft, and this would allow you to tighten it down and take up for wear and all that, and would keep steam from leaking out around the piston rod. I may not do that. At least I probably won't do it to start with. It's rather tedious, and since I'm going to be running this on air, it really isn't necessary. But if you're running it on steam and it does leak, you're going to see steam coming out of the hole right here. Okay, I'm going to get started on this. Again, I'm not going to show all of that. So the first thing I'll do is clean this up, and then this is also going to have an 1/8 inch hole right through the center, and the purpose of that, of course, is for the piston rod, and I will ream that 1/8 inch. This piece was a bit of a struggle, and I'll tell you why. The spigot on the other end was so far off center that it was absolutely useless. If I did in fact use it, the center would have ended up about here on this side. Now that didn't show up, but anyway, at least 1/8 of an inch off of center. So I sawed that off, faced it, and then it was most tricky, but I held this in a 3-jaw chuck by different methods until I had turned the diameter, the thickness, and the step. The step again is way too thick and it will be reduced later on, but I need that extra thickness in order to hold it in the chuck, but eventually it will be reduced like the other one. But now let's talk again about laying the holes out, and I'm going to do that by a different method, 2 different methods, just so you got some variety here, and there's probably a dozen different methods of doing that. But first I'll go ahead and put the circle on there, scribe it exactly the way I did on this one in the closing lathe using the threading tool. And I won't show that because it's been shown. Be back in a minute. I'm holding this little casting by the step, of course, as I just mentioned, and I've already put the pitch circle on there, or I should say the bolt circle. And now, as long as I got it in there, I'm going to center drill it and drill it, let's see, what was that, 7/64, and then ream it 1/8 inch. So that is done, and then I'm ready to lay out those bolt holes as I previously mentioned. I'm at the Atlas Craftsman 12-inch lathe, and you know, I've had this machine for 25 years and I have never used the indexing feature, and that's how I'm going to lay out the 6 holes on the other little casting, which is already in the 3-jaw chuck. You can't see it, but as you know, there are 60 holes here on this big gear, and right here we have an indexing pin. Well, come on out. There. That will fit into any one of those holes. This is Zamak. Now, since there are 60 holes, we can divide that by 10. In other words, the 6 is divisible into the 60. So I have marked every 10th hole. See the black marks all the way around? So, and the white one is the starting point. So if I put the pin into the white hole as such, I will scribe, then I will move it to the next hole, scribe, and in other words do that 6 times, and I will have the layout. So let me move the camera just a little bit because you won't see me doing this, you're going to see me scribing. Okay, in the Aloris tool holder here I have a very sharp center punch is what it is. Could be a scriber, could be almost anything. And so I'll bring that up against and basically try to scribe a line. I'm putting a little pressure toward the headstock, so I'm scribing, back it off just a little bit, and then I will move to the next hole, if my head isn't in the way, and then scribe this one. this making any sense to you at all? Or is it too crude? But so many of you have Atlas lathes that have this indexing feature. And then to the next one. And so on ad infinitum. Now let's see what they look like, and of course they have to be center punched yet. You got to get it really close to see them. Since it's a rough casting, they're just a little bit hard to see, but yeah, there, I got to get the light just right. 6 equally spaced marks. Now here's a cheap and easy solution to laying out those 6 holes, and this is a hexagon collet block. You can get these in square. I wish they made them in octagon, but you could also use your spin index or any other device that you have. And I put a piece of soapstone in the height gauge here, so if I can get my hands out of the way, and the soapstone is pointed and set on center. So watch this. 1, 2, 3, 4, 5, 6. Well, how easy is that compared to the other methods? And quite accurate, but of course you would be doing this with the scriber, not with the, where's my scriber? You'd be using the scriber, not chalk. But I just did that because I didn't want it to interfere with my other marks, which I will now center punch. And I did orient this such that the bolt hole will not run into the steam passages, same as I did on the other end. It's terribly hard to see the layout lines on a rough cast surface, but I've drilled a little bit of a pilot hole into each one. And now I'm going to go ahead and drill them, and I'll drill and tap the holes on this end so that both covers are done. And that will conclude this video, part 6. Join me in part 7 as I make the piston rod and some other little bar stock type parts, intricate little parts. So I'll see you in the next video. This is Tubalcain.